Welcome to Session 21, Sequences and Algebraic Patterns. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to distinguish constant difference from constant ratio patterns, to write explicit rules with the correct one offset, and to separate a requested term from the sum of many terms. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Constant input steps and output differences reveal a linear arithmetic pattern. Compare consecutive rows rather than isolated values. Difference measures additive change. Ratio measures multiplicative change. The row index plays the role of sequence input. The key distinction is this: distinguish constant difference from constant ratio patterns. Then connect it to the second goal. Write explicit rules with the correct one offset. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Compute first differences and ratios across consecutive terms. Identify the object being changed and the requested result. Step 2. Choose arithmetic or geometric structure and identify its parameters. Use a separate line so signs, units, and restrictions stay visible. Step 3. Use n-1 so the rule reproduces the first term. Work efficiently without skipping an operation. Step 4. Determine whether the question asks for one term or a cumulative total. Whenever possible, verify with evidence independent of the original working. Signal 1 is constant difference. Respond by remembering. Use an arithmetic or linear rule. Name the response before calculating. Signal 2 is constant ratio. In that case, use a geometric or exponential rule. The form tells you which tool fits. Signal 3 is total through row n. Remember, sum terms rather than reporting only the nth term. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. A theater has 20 rows. Row 1 has 18 seats, and each later row has 4 more. How many seats are there altogether? Restate the target and identify the most important part of the routine. The first move is, the last row has 18 plus 19. 4 equals 94 seats. This changes the form without changing the meaning. Next, the average of first and last terms is 18 plus 94 / 2 equals 56. Keep the relationship visible and apply the operation to every required term. Now, audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. There are 20 rows, so the total is 20. 56 equals 1120. State what the transformed line tells you. Complete the argument. Reporting 94 would answer only the last minus row question. This is part of the solution, not decoration. The final answer is 1,120 seats. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What is the 10th term of 5, 8, 11, 14? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Use 5 plus 10 minus 1, 3. Use it to repair your setup rather than guess. An accepted answer is 32. Explain why it works and name the first step that would expose a common error. Central message is, distinguish constant difference from constant ratio patterns. Combine it with the discipline to write explicit rules with the correct one offset. Finish by remembering to separate a requested term from the sum of many terms. This turns a calculated result into a justified answer. Reflection. Distinguish a recursive rule from an explicit rule in one sentence. Name the error specifically so you can interrupt it next time. Practice one fresh problem within 5 minutes, including a term versus total check. Keep the work readable, check it independently, and carry the routine forward.